Symmetry of the unit circle. We're going to look at the symmetry properties of the unit circle. Think about that. Symmetry. You know, from this point here to this point here, or this point here to this point here, or that point here to that point here. We're going to look at the properties of symmetry from point to point. We're going to look at how we can relate those around the circle. So let's just start off by looking at this point here. This point here, obviously, if it's in the first quadrant, we've got angle theta. If it's the x coordinate would be this length here, because we want to go that way, would be cos, adjacent over hypotenuse. So that is our x coordinate here. Our y coordinate's opposite over hypotenuse, so that would be sine theta. If you can get your head over around this whole thing, you're doing really well, and that's what I'm hoping to do. When I see this, I just think of a lot comes to my mind, and hopefully by the end of this video, you will too. So we're going to call this point A, B. So we really go, well, A across, hence that's A0, that point there, and we go B up, hence this point here is 0 on the x and B. So this point here is AB, which obviously A refers to cos and B refers to sine. Now when we're talking about symmetry, well, if I've got this point over here, right, I mean, what are we looking at? Well, I've gone up the same amount, right? Okay, because I've gone up this far, and I've also gone across that much. That must mean that this angle in here must also be theta, because it's symmetrical, right? It's just been folded over on each other. So what is this point here? Well, if you go from here, we know that if you went all the way around with the angle here, it would be pi. Obviously, that we've came back theta, we've came back this amount. So the angle here is P minus theta. That's the position of that. That's going to be where it is. So let's just look at, for example, a value, sine 30. Now, if you know from going back to year 10 or whatever, sine 30 equals a half, right? So if I wanted to know, well, what was sine, let's go with pi. Now I'm working with radians and degrees, which probably isn't the same thing. But in this case, I'm going to go pi minus 30 degrees. Or let's just change that. Let's just go with 180 degrees because we know pi is 180. That minus is sine 150. Now sine 150, let's think about what that value would be. If you think about symmetry properties, sine is a measurement of y, right? It's the y coordinate because it's opposite over hypotenuse. It's here. Now if you come around, we're measuring how far up we've gone. If you have gone around 180 from this point, but then you've came back up the same height, sine is a measurement of the y-axis. Wouldn't that actually be still 0.5? So that would actually still equal a half, which is what it is. So we're looking at symmetry properties. So notice that sine theta minus pi is the same height. Therefore, it's equal to the same thing. Because if you come back the same degree here, if you go the degree up there, so even if we took theta up to here, and I went pi minus theta, I'd be up here, I'd still be up to the same height on y-axis. Okay? But if you think about the x-coordinate, well, the x-coordinate here gives you the length there, really, is what we're looking at. So if you go, well, around to theta, but then you minus the same degrees back, the x-coordinate is now going to be there. Now, it's going to be the same distance from the origin, except this side is positive, and this side is negative. Hence, when we have cos pi minus the angle, it's going to actually be negative cos A, because the length here is the length of negative A, because here it goes to A. If you have it over there, it's going to be negative A. So we're starting to look at how these all relate with each other. So if we move down to the third quadrant, what will happen there? Well, if I've got an angle, theta, and if we just think about sine theta, that gives me my height here. Well, if I go from pi and I add that angle on, because I'm obviously now going to add that angle on, I'm going to add on pi. Here we're taking it away. That means this point here is going to be pi plus an angle. Now, if I go from halfway and add it on, clearly we can see that, well, my point upwards is going to go downwards here. So we're going to actually get negative b. So therefore, when it comes to opposite, which is sine, this length here is now going to be, if I go with pi plus theta, it's going to be negative sine. Because before, if we looked at, say it was 30 degrees here, that's going to have a value of a half. This would be a half length. However, if I go 180 plus 30 degrees, it's going to give me a value of negative a half, which would be 210, because that's going to be how far it would be measuring off on the axis here. So we can have a generic rule where this is going to be negative sine theta. If we look at cos, okay, so if we looked at cos theta here, it would be there, but it would be negative a. So cos pi plus theta would still be negative cos theta. Moving to the fourth quadrant. If I look at going all the way around here, well, if we started at 2 pi and took away this. Now, if we look at sine, obviously you're going to be becoming negative. So if I took away the degrees here, obviously we're going to have a negative number because it's not going to be a half, it's going to be negative a half. So this negative in front is just going to change it to a negative value. Because obviously, you know, if we go 30 degrees up from here, from the origin, well, we're going to be half up. But if I go 30 degrees down from here, I'm going to be negative a half from the origin. So therefore we need the negative in the front. This is the same thing. If I go cos 2 pi minus theta though, notice it gives me the same x coordinate. So that's just going to be the same thing as cos theta. If you want to look at the tangents and how they work, they're a little bit more complicated. We've got to really look at the relationship between cos and sine. So if you look at cos and sine, so if you had a tangent here, it's opposite over adjacent. Notice the opposite being the y coordinate sine. So this is positive, okay? This is positive. You're going to get a positive answer as a result. Over here though, if you think about sine, I'm going to have a positive sine coordinate, okay? I'm going to have a positive, I'm going to have a negative x coordinate, and I'm going to have a positive y coordinate. Therefore, it's going to give me a negative result. So therefore, it needs to be negative in front. Over here, I'm going to have a negative x coordinate and a negative y coordinate. Negative minus negative cancels each other out. Hence, tan there will be the same as pi plus theta. Over here, I'm going to have a positive x coordinate and a negative y coordinate. Hence, it will be negative tan. Okay, so that's where we can get their values of those from. So what we're really trying to do, what we could do, is figure out if we have other angles, what the value is of this original one. So let's just have a quick look at this. Let's just say here I have an angle, right? Okay, and let's just say this is, I don't know, 40 degrees, okay? And let's just say that this is 0.6, just off the top of my head. Now, if I said, hey, what is the value of sine 180 plus 40? Well, you would be like, oh, I don't know. But hang on, let's think about it. If you went around to 180 on the unit circle, you would be over here. Then if you add 40, you would be here, in there. Now you know that the original 40 degrees had a vertical height of 0.6. So if you went 40 degrees down from here, and you know that sine is opposite, that would be negative 0.6. Therefore, you know that this is negative 0.6 is the value of that. And this is how we're looking at symmetry properties of the unit circle. Because we can use something we know about in the first quarter, and we can apply it into every other quarter based on if we take away or add from basically the x-axis is what we're looking from here. So let's say we've got a scenario like this. We have this angle here, right? And we have something that is basically a pi length away in terms of its angle. So if I said, well, if this is the theta here, right? And if I said, well, what is sine theta? Well, sine theta would be just equal to my x-coordinate, sine, opposite over hypotenuse, sorry. Opposite would be my y. So it would be equal to root 3 on 2, right? But if I said, hey, what's sine theta? That's root 3 on 2. Plus I'm adding a pi onto it. A pi is like half a revolution. Whew. That means all of a sudden I'm actually going to be over here a bit more. Now, if you think about that, that is the y-coordinate that comes down here, and that means this y-coordinate will be now here. So therefore, the y-coordinate was 3 on 2, because it's going up there, but now it's actually going to be negative root 3 on 2. So that would equal to negative root 3 on 2, because that's, 3 on 2, because that's what it would be. If we look at cosine, which is the x, theta, cosine theta would equal negative a half. But if I looked at cosine theta plus pi, now I've got to think of, okay, if I've added pi onto it, if that's cosine theta and that was negative half over here, I'm adding a whole pi onto it. Now it's going to be in the positive quadrant. Therefore, that would equal a half. So we've got to look at basically the angle. It's always good to do a bit of a sketch where you're at. That is really key. Sometimes doing a sketch and understanding where you're at and then seeing what you're adding on or taking away and so on. Now, if I did minus pi from here, I'd have to come back and it'll be the same values. Good luck.